Welcome to Episode 11, Shared Responsibility and Inheritance, a practical guide to dividing security and privacy work sensibly when technology and services are shared. Teams succeed faster when everyone understands which party does what, why it matters, and how proof will be collected. Without that clarity, gaps appear between contracts and configurations, and incidents later reveal that both sides thought the other was watching. Shared responsibility matters because modern environments rely on platforms, clouds, and managed services that deliver value only when paired with customer controls. Good boundaries reduce duplicated effort and make audits predictable, while poor boundaries multiply meetings and slow projects. In this episode, we turn a confusing topic into a repeatable routine your team can apply across providers. The goal is simple: right-size who owns which controls and capture evidence that travels cleanly through assessment.
Cloud service models shape the split before any contract is signed. At a high level, infrastructure as a service places more operational work with the customer. Platform as a service shifts more baseline controls to the provider, and software as a service moves the most into the provider's domain. Regardless of model, customers still own identity choices, data classification, role design, and how privileges are granted. Providers operate the layers they expose, but customers must align usage with business risk and compliance obligations. Understanding these patterns prevents unrealistic expectations, such as assuming a software provider manages your internal access reviews. The lesson is not to memorize every difference, but to ask, for each control, which layer can actually influence it. That question keeps discussions grounded in what the service model truly offers.
Responsibility matrices and contracts translate the model into enforceable agreements. A responsibility matrix lists controls or activities and assigns the owner as provider, customer, or shared, with notes about evidence sources. Contracts then reference these assignments in clear language, naming required attestations, reporting timelines, and notification duties. The matrix should be concise enough to use during design sessions and specific enough to settle disputes in audits. When paired with service-level expectations, it also drives operational cadence for reviews and tests. The point is to embed ownership into the relationship, not leave it to interpretation during an incident. A well-constructed matrix and contract set the tone that assurance is part of the service, not an optional afterthought.
Control boundaries and ownership are practical, not philosophical. A boundary is the point at which one party's configuration authority ends and the other's begins. Ownership means the named party ensures the control is designed, operated, and evidenced at the required maturity. For example, a platform may own disk encryption at the infrastructure layer, while the customer owns key assignment, rotation schedules, and user role restrictions. Boundaries should be drawn where tools and permissions naturally sit, not where an org chart suggests. Documenting these edges with system names and interfaces helps prevent drift when teams change or when new services are added. Clear boundaries simplify testing because the assessor knows exactly where to look for proof and whom to ask. Inheritance is the practice of accepting a provider's control as meeting a requirement for the customer when the scope, coverage, and rigor align. It is allowed when the provider can show objective evidence that the control exists and operates for the assets in question. Inheritance is not a shortcut. It is a disciplined recognition that duplicating the same work adds no value. The customer still carries obligations around configuration, monitoring, or usage that sit above the inherited layer. Each inherited control should include a short rationale that states what is covered, what is not, and how applicability to in-scope systems is proven. Used correctly, inheritance reduces cost and speeds audits while keeping risk visible. Provider attestations and documentation enable inheritance to be trusted. Attestations might include independent reports, certification letters, or detailed control descriptions with testing results. Documentation should identify the exact services, regions, and features covered, along with dates, versions, and known limitations. Customers should verify that the attestation period overlaps the assessment window and that the described controls match the services actually in use. Where a provider offers multiple levels or options, the customer must confirm which ones are enabled in their tenant. The aim is to ensure that the promised control is the one protecting the in-scope assets, not a generic capability described in marketing. Attestations that are current and precise remove doubt and streamline assessment conversations.
Evidence mapping to inherited controls ties the provider's proof to the customer's requirement statements. Each inherited item should reference the provider artifact, the control it satisfies, and the customer evidence that shows scope alignment, such as subscription identifiers, account numbers, or configuration snapshots. If key material or role settings remain customer responsibilities, include those artifacts next to the provider's attestation so the chain is complete. Naming should be consistent across files so a reviewer can move from requirement to provider proof to customer configuration without translation. Mapping is where inheritance becomes auditable rather than assumed. When done well, it allows the same provider evidence to be reused cleanly across multiple controls. Every inheritance decision has limits, gaps, and residual risk that must be acknowledged. A provider may encrypt storage by default, but the customer may still need to manage keys, rotations, and access policies. A provider may log platform events, while the customer must centralize and monitor application logs. Some controls cannot be inherited at all, such as end-user training or business process approvals. Writing these limits down prevents a false sense of coverage and keeps improvement work visible. Residual risk should be stated plainly, with mitigation steps and owners, so leadership understands what remains and why it is acceptable. Transparency turns inheritance from a leap of faith into a measured design choice. Monitoring provider changes and incidents is part of owning the shared model over time. Providers update services, deprecate features, and publish advisories that can alter the control picture. Customers should subscribe to change feeds, review impact on inherited controls, and record any actions taken. Incident notifications from providers should trigger internal checks, such as confirming exposure, adjusting detections, or communicating with stakeholders. Time synchronization and version notes help correlate provider events with local logs if investigation is needed. Treat these activities as routine governance, not emergency tasks, so the model stays accurate without last-minute scrambles. Continuous awareness preserves the integrity of inheritance across the service lifecycle. Multi-provider and hybrid scenarios add complexity but follow the same principles. When workloads span data centers and clouds, or when multiple software services integrate, boundaries must be defined for each link. A single control, like identity, may involve a corporate directory, a platform mapping, and an application role model. Documenting handoffs between providers and the customer prevents gaps where no one monitors or tests. In hybrid designs, local configurations can drift from cloud defaults, so periodic alignment checks are essential. Keep matrices modular so each provider's portion can be updated without rewriting the entire model. Modularity makes complicated environments manageable and keeps assessments focused. Assessor expectations and verification center on clarity, consistency, and proof that matches scope. Assessors will ask for the responsibility matrix, the contracts or statements of work that set obligations, the provider attestations, and the evidence that links those attestations to your tenant or accounts. They will test spot controls on both sides of the boundary to confirm that inheritance claims are accurate and that customer responsibilities are truly performed. Expect questions about timing windows, versions, and any exclusions. The strongest answer is a short, traceable chain from requirement to owner to artifact. Meeting this expectation signals a mature program that understands assurance, not just technology. Integrating inheritance in MyCSF turns design into daily practice. Use scoping records to name providers and services, mark applicable controls as inherited, and attach provider attestations directly to those references. Add short narratives that explain boundaries and customer obligations that remain. Link customer artifacts like role settings, key policies, or log integrations to the same control so the package is complete. Assign tasks to owners for periodic verification of inherited coverage and for monitoring provider changes. In this way, inheritance becomes part of workflows, milestones, and quality gates rather than an afterthought. The platform then produces reports that reflect the true split, which saves time during review. Right-sizing inheritance responsibly means using providers where they are strongest and keeping customer duties where business context is required. Treat the shared responsibility model as a living document, confirm it with contracts and matrices, and prove it with mapped, current evidence. Accept inheritance only with precise attestations and clear scope alignment, and name the limits so residual risk is visible. Monitor provider changes, verify multi-provider handoffs, and prepare for assessor questions with a complete traceable chain. When you work this way, you reduce redundancy, keep focus on real risks, and make assessment smoother. Shared responsibility becomes not a slogan, but a disciplined method for operating and proving security in modern environments.